Can you guys see the screen now?
Yeah, we can see it.
So
So,
this is basically like the program that we worked on with Saturn to make the first true Bitcoin DEX on Bitcoin, and it's basically like using Arch infrastructure. First of all, these are like imports, basically like helpful functions to help you do multiple stuff within the contract. You can see here you can get Bitcoin transactions, get the network's X-only pub key, invoke other smart contracts from within the program. It trades on account infos, such return data, set transaction to sign. We'll go through this. This is really important. Also like some helper stuff.
Amin, I have a question here to sort of frame this for people. Before Arch Network, how was this done, or was it even possible? And now, like, what's the unlock here?
So basically,
Can you just like give the high level before we go into the code? Thanks.
yeah, so basically before what you would do is you would basically like construct Bitcoin transactions. You need to be able to like do any multi-party contracts. I see that Amir raised his hand. Do you have a question? Also, like feel free to interrupt me and ask questions. Oh,
sorry. Yeah, I had a question earlier when you presented. Um, so you choose to go with Rust versus Solidity, and why is that? And that ties to Albert's questions, like how was it done before, and just a high level
mhm.
explanation.
Okay. So the reason we chose Solidity, first of all, we need to be like as low level as possible, and Rust is essentially a low level programming language. Solidity has like a lot of downsides. You can't really it's only written for programs to be like sequential. You can't really use it for parallel programs, and Bitcoin works in a parallel fashion. You're basically like each Bitcoin node, when you send in a transaction, it's basically like processing transactions in parallel since UTXOs are independent on each other. And if you like use a language that's basically like made to be run in sequence, it really doesn't fit Bitcoin. So what we try to do is basically like have as much of a native experience with Bitcoin. Regarding like how Bitcoin programs were written, you basically like use discretes only, and you'd basically like construct Bitcoin transactions. You would put the inputs and the outputs, and that can like unlock some use cases, mainly just like peer-to-peer like apps. So like on Bitcoin right now, we're seeing like peer-to-peer marketplaces, Magic Eden. We've seen like peer-to-peer lending protocols like Liquidium, but we haven't really like unlocked real DeFi, which is all based on like these pools. You need to trade like against a smart contract, which enables this multi-party contract. And that is not possible right now on Bitcoin. So this is what Arch unlocks. You have like a smart contract that enables you to basically uh, have these like multi-party contract and do whatever you want, pretty much. Does that make sense?
One last thing. So this is considered as a layer two.
No, so you're gonna see like as we go through the code, you're basically like sending back a Bitcoin transaction. Uh, Arch Arch could be used as an L2, but the main unlock here is that you're basically like invoking Bitcoin transactions directly from the smart contract, meaning that you could write smart contracts directly on Bitcoin now. Okay. So yeah, let's go through the code, and it's like that will be more clear as we go. Okay, so these are just like imports, basically like code that the Saturn guys have written, basically like some data structure. Here you can see like the liquidity pool config, liquidity pool list, and shards. Also on the last talk, you remember guys how we talked about like these states concurrency issues that Bitcoin has. You can't really like call the same program a lot of times. Mainly the states, just to like re-explain the states concurrency issue again. Imagine you have like 100 people trying to like use the same swap at once. What you're gonna have on the backend. The backend is gonna send you the same Bitcoin transaction to sign, which basically like uses the same UTXO. And this creates basically like 100 conflicting transactions, and only one transaction can get into the Bitcoin ledger. This is like a big problem as apps scale. It prevents like apps from scaling because you can't handle all the load on Bitcoin. So how we fix this is basically we shard these pools, and each person basically trades against these shards, and like the number of shards can scale linearly with the demand. And this like gives you a big edge over like all other competitors in the market, by the way. Okay, so this is the entry points. This is the macro that you use to basically like indicate to the network that this is the function that we need to run.